In today's lesson, we are going to talk about how to find the rate of change if the equation is known. In the previous section, we talked about using table of values and the graph to find the average rate of change for a given value. Now, as you're aware of, this rate of change, it all depends on how accurate the data in the table of values or the sketch of the graph is. Now, what we are going to do in this section is to find a much better strategy to find the rate of change if the equation is known. If the equation is known and we want to find the average rate of change of the function f of x over the interval of x between a and b inclusively, we know that we have to use the value of the function at the end points of the interval, meaning f of b minus f of a over b minus a. And this was giving us the average rate of change of the function over the interval of a and b. Now, a is the point that we have to find the rate of change, and b is another point which is very close to a on the graph. Let's assume that b is equal to a plus h, where h is a very small increment. Later on in the next sections, we are going to talk about limit when h goes towards 0. If I replace b with a plus h, I'm going to get delta y over delta x is equal to f of a plus h minus f of a over b is a plus h minus a. Now, if I cancel out a here, I get this is equal to f of a plus h minus f of a over h, as it given here. And there is a mistake here. This has to be a. Now, we call this expression, this one, as the difference quotient. When h goes to 0, then the point b is getting closer and closer to a, and the rate of change which is obtained from this formula is going to be very close to the real value of the rate of change at point A. In this graph, you can see when 2 points A and B, which are here, when they get closer and closer together, meaning the value of h becomes almost 0, then the line is going to be tangent to the graph at point A. Let's do our first example. We have Ahmed, which is cleaning the outside patio windows at his aunt's apartment, which is 90 meters above the ground. He accidentally kicks a flower pot. We are supposed to find an algebraic expression in terms of a and h that represents the average rate of change of height above the ground. If we know that the height of the flower pot at any moment of time follows this equation. But remember that h0 is 90 meter and g is 9.8 meter per square second, and t is time in seconds. To find the average rate of change in terms of A and H, we are going to use the quotient, the difference quotient. So we are going to say delta Y, in this case is delta H over delta T, is equal to f of A plus H minus f of A divided by H. Now f of A plus H, the equation is here, so I'm going to replace T with A plus H. So I'm going to get H0 minus, but remember that the G is 9.8, so 1 over 2 times 9.8 is going to give me minus 4.9 A plus H squared. So this is my f of A plus H. Now I have to subtract f of A, which is going to be minus H0 plus 4.9 A squared divided by H. Now I'm going to expand this one. I'm going to get H0 minus 4.9 A plus H squared is going to give me A squared plus H squared plus 2AH minus H0 plus 4.9 A squared over H. Now I'm going to expand negative 4.9 inside the bracket. I'm going to get H0 and minus H0, they cancel out. So I get negative 4.9 A squared, negative 4.9 H squared, and negative 4.9 times 2 gives me negative 9.8 AH plus 4.9 A squared divided by H. Now negative 4.9 A squared and 4.9 A squared, they're going to cancel each other out. I have an H in the denominator, so I factor H out and then cancel it to the denominator. So I get this is equal to negative 4.9 H, because one H goes with the square, minus 9.8 A. So this is my rate of change at point A in terms of H. Part B of the question says determine the average rate of change of the flower pot's height above the ground in the interval between 1 and 3 seconds. Since 1 is less than 3, we can say that A is equal to 1 and B is equal to 3. So from here, we know that B is equal to A plus H. So we know B is 3, A is 1. So from here, H is 3 minus 1, which is going to be 2. Now I'm going to go ahead and use this formula to find the average rate of change. So I'm going to say delta H over delta T is going to be negative 4.9 times 2 minus 9.8 times 1, which is negative 9.8 minus 9.8, which is going to give me negative 19.6 meter per square second. And the negative here tells us that the height is decreasing, which makes sense because the flower pot is going toward the ground. The next part of the question says estimate the instantaneous rate of change of the flower pot's height at 1 second and 3 seconds. We said in section 1.1 that the instantaneous rate of change is going to be when the h value is going to be very, very small. So let's say a is 1 because we want at 1 second. In this case, we are going to pick an h value which is very small. Let's say 0.001. Then our b value is going to be a plus h, which is 1.001. We have already found the formula in part A that the rate of change delta h over delta x, delta t, is going to be equal to negative 4.9 times h minus 9.8 a. In our case, it's negative 4.9 times 0.001 minus 9.8 times 1, which is going to be approximately 9.8 meters per second. And the case of a equal to 3 seconds, if we use the same value for h, we are going to find delta h over delta t is negative 4.9 times 0.001 minus 9.8 times 3, which is going to give us approximately negative 29.4 meters per second. The next part of the question says determine the equation of the tangent at t equal to 1, and then sketch a graph of the curve and the tangent at t equal to 1. First of all, recall that the equation of the curve was h is equal to h0. We said that h0, the initial height, was 90 meter, so 90 minus 0.5 gt squared. To find the height at t equal to 1, I'm going to replace t equal to 1 here, so I'm going to find that h is 90 minus 0.5 times 9.8 times 1 squared, which is 1. If we simplify this one, we get 85.1 meter. So at t equal to 1, the height is 85.1 meter. Now, the equation of a line in slope y-intercept is y equal mx plus b. In our case, y is really h, so I'm going to write h is equal to m. In previous question, we found that the rate of change at t equal to 1 is negative 9.8, so m is negative 9.8. X is really t plus b. b is the y-intercept, which we have no idea what the value is. To find b, we know that at t equal to 1, the initial height is 85.1. So I'm going to substitute 85.1 at time t equal to 1 plus b. From here, I get b is 85.1 plus 9.8. So b becomes 94.9. So from here, I get the equation of the line is h is negative 9.8 t plus 94.9. I'm going to leave the sketching of the graph and the tangent to you. You can use technology to do it, or you can just come up with a table of values for 4 or 5 points and then plot the graph and then draw the line y equal or h equal to negative 9.8 t plus 94.9. The next question is asking us to write a difference quotient that can be used to obtain an algebraic expression for estimating the slope of the tangent to the function y f of x is equal to x cubed at x equal to 5. To write that one, we say that d delta y over delta x is f of a plus h minus f of a divided by h. Now our a is 5, so I'm going to write 5 plus h and evaluate it for this function, so it's going to be 5 plus h cubed minus a is 5, so 5 cubed divided by h, which is the same as 5 plus h cubed minus 125 divided by h. The next question says, determine the average rate of change from x equal to 1 to x equal to 4 for y equal x cubed and y equal to 7. First, we are going to look at y equal x cubed. We know that a is 1, b is 4, which is equal to a plus h. But a is 1, so 1 plus h is equal to 4, so from here we get h is equal to 3. Now we know that delta y over delta x is equal to f of a plus h minus f of a over h. Now f of a plus h, which is going to be 4, so 4 cubed, minus f of a. F of a is 1, so it's going to be 1 cubed over h. H is 3. So this is going to be 64 minus 1 over 3, which is 60. 3 over 3, which is going to be 21. For the second one, y is 7. So delta y over delta x, again, f of a plus h is going to be 7 because there is no x involved, minus f of a, again, there is no x involved, so minus 7 again, divided by 3, which is going to give you 0. And if you really look at this one, y equal to 7, this is going to represent a horizontal line. And as you can see, the rate of change of a horizontal line is 0. There is no change in the y values. Y is always staying at equal to 7. The next question says, you have a snowball which is melting. The surface area and the volume decreases, obviously because the radius decreases. Now the formula for the surface area is given by the equation surface area is equal to 4 pi r squared, and the equation for the volume is given by v is equal to 4 over 3 pi r cubed. Part A says determine the average rate of change of the surface area and of the volume as the radius decreases from 25 centimeter to 20 centimeter. To find the average rate of change of surface area, we say that delta SA surface area, divided by delta R is equal to surface area at 25 minus surface area at 20 divided by 25 minus 20, which is equal to 4 pi r squared, which is 25 squared, minus 4 pi 20 squared over 25 minus 20 is 5. If we evaluate this one, we get approximately 565.5 square centimeter divided by centimeter. So that's the rate of change of surface area. Now to find the rate of change of volume, we say delta V to delta R is equal to V of 25 minus V of 20 over 25 minus 20. This one is 4 over 3 pi 25 cubed minus 4 over 3 pi 20 squared divided by 25 minus 5 is 25 minus 20 is 5. If we evaluate this one, this is approximately 6387.9 cubic centimeter to centimeter. The next part, part B, says determine the instantaneous rate of change of the surface area and the volume when the radius is 10 centimeter. Again, we know that the surface area is given by 4 pi r squared. So to find the instantaneous rate of change, we are going to use the h value. So we are going to say that the instantaneous rate of change is equal to 4 pi r plus h squared minus 4 pi r squared divided by r plus h minus r. Remember, h here is a very small increment to the radius. If we expand this one, we get 4 pi r squared plus h squared plus 2rh minus 4 pi r squared over h. This one is going to give us 4 pi r squared plus 4 pi h squared plus h pi rh minus 4 pi r squared over h. 4 pi r squared and 4 pi r squared are going to cancel out. The h here and this h and the exponent are going to cancel, so we get 4 pi h plus 8 pi r. But remember that r here is 10, so we get 4 pi h plus 80 pi. Now the next part of the question says find the instantaneous rate of change of volume. We do exactly the same thing. We say delta V over delta R is equal to 4 over 3 pi r cubed, so r plus h cubed, minus 4 over 3 pi r cubed over r plus h minus r. This is going to give us, after expanding r plus h cubed. Now to expand this one, either you can do repeated multiplication of 3 brackets, which is going to be a painful process, or we can use the Pascal's triangle and we can expand r plus h cubed. If we do the expansion, we get 4 over 3 pi h cubed plus 3h squared r plus 3h r squared plus r cubed minus 4 pi over 3 r cubed divided by r is going to cancel, so we get h in the denominator. When you simplify the numerator and then cancel out the h in the denominator, we get the answer to be 4 over 3 pi h squared plus 4 pi h r plus 4 pi r squared. Now again, since r is 10 in the problem, we are going to substitute 10 here. We get this equal to 4 over 3 pi h squared plus 40 pi h plus 10 squared is 100 times 4 is 400 pi. In the next example, we have an oil tank which is being drained. The volume which is still left in the tank is given by this equation here. First, based on this equation, you can see that this interval shows that the oil takes about 25 minutes to be drained. The first part of the question says, determine the average rate of change of the volume during the first 10 minutes. So to find the average rate of change, we say delta V over delta T is equal to V of 10 minus V of 0 divided by 10 minus 0. V of 10 is 60, 25 minus 10 squared minus 60, 25 minus 0 squared divided by 10. If we simplify this one, we get negative 2400 liters per minute. So that's the average rate of change for the first 10 minutes. To find the average rate of change for the last 10 minutes, we have to find delta V over delta T between the last 10 minutes, so 15 and 25. So it's going to be V of 25 minus V of 15 divided by 25 minus 15. This is going to be 60, 25 minus 25 squared minus 60, 25 minus 15 squared divided by 10. If we evaluate this one, we get negative 600 liters per minute. Now the question is asking, compare these values, giving reasons for any similarities and differences. The first 10 minutes, we found that the average rate of change is negative 2400 liters per minute. For the last 10 minutes, it's negative 600 liters per minute. Both of them are negative, so it means that the volume is decreasing because the oil is being drained. And also, the first 10 minutes was negative 2400, and the last 10 minutes is negative 600. You can see that it's more negative at the beginning than at the end because there is less oil to be drained at the end than at the beginning. At the beginning there are more oil, so the rate of change in the volume of the oil is much bigger than the last 10 minutes. The next part of the problem says determine the instantaneous rate of change of volume at each of the following times. The first one is t is equal to 5. So we are going to say the rate of change, delta v over delta t, is equal to 60 times 25 minus, now our t is 5 plus h squared, minus 60 times 25 minus, our time is 5 squared over h. If we simplify this one and cancel h, we get 60h minus 2400. Now to find the instantaneous rate of change, we are going to let h to be very small number, very close to 0. This means that this term is not going to contribute anything because 60 times almost 0 is going to give us 0. So the answer is going to be negative 2400 liters per minute. The next part of the question is asking us to find the instantaneous rate of change at t equal to 10. Again, we are going to say delta v over delta t is equal to 60 times 25 minus r. In this case, r is 10, t is 10 plus h squared minus 60 times 25 minus t, which is 10 squared, divided by 10 plus h minus 10 is going to give us h. If we simplify this one, we get this one is equal to 60h minus 1800. Again, as we let h go to a very small number close to 0, 60h is not going to contribute anything. It becomes 0. So the answer becomes negative 1800 liter per minute. The next part of the question says, find the instantaneous rate of change at 15 minutes. So again, delta v over delta t is 60 times 25 minus 15 plus h squared minus 60, 25 minus 15 squared over h. If we simplify this one, we get 60h minus 1200, as the same way that we let h goes to almost 0 in the previous parts. This one is not going to contribute anything, so the answer is negative 1200 liters per minute. And the last part says at t equal to 20. Again, delta v over delta t is equal to 60 times 25 minus 20 plus h squared minus 60, 25 minus 20 squared over h. If we simplify this one, we get 60h minus 600. Again, let h go to 0, then this term is going to be 0, so you get negative 600 liters per minute. The last part of the question says compare these values and then see if there is any similarities or differences. As you can see, the instantaneous rate of change starts from negative 2400 and it goes down to negative 600. It is telling us that the rate of change is decreasing, And one of the reasons that we can give is that there is less oil which is going to be drained. That's why the rate of change is decreasing.